Hey everyone, welcome to another video of Triple MS. The today's topic of mathematics B is mensuration. In this video, we will talk about the three-dimensional shapes. In the previous video, I've already talked about the two-dimensional shapes. If you haven't watched that video, please make sure to watch this video. Without any further ado, let's start today's video. So here the 3D shapes. Under this topic, we mainly calculate two types of things. First is volume, second is total surface area for each of the 3D shapes. So the first 3D shape we have is a cube. So we have seen a cube, right? You have seen a cubic, the ice cube, and a dice, and a sugar cube, and many more, etc., etc. This is the cube. The volume for the cube equals to L cube. And if you open the top part of the cube, that time the total surface area should be equals to 5 into area of 1 square. Therefore 5 into L square. And if you close the top part of the cube, that time the total surface area of it is 6 into area of square. Therefore 6 into L square. Hope you guys are clear up to this. Now the second 3D shape we have is a cuboid. Here we have seen many types of things of this shape, such as a shoe box, then a gift box, then a first aid box. It can be a tissue paper box, etc., etc. The volume for the cuboid equals to length into breadth into height. Here LBH. If just like cube, if you open the top part of the cuboid, the total surface area should be equals to length into breadth plus 2L into H plus 2B into H. In the, and if you close the top part of the cuboid, the total surface area should be obviously equals to the open parts formula, and then you will be adding one more LB. Therefore, the total formula equals to 2LB plus 2NH plus 2BH. I hope you have no doubt up to this. Now the third 3D shape here is a cylinder. Here we I hope you guys have seen the cylindrical shape. The cylindrical shape can go cylindrical. It can be anything. Yeah, say of this shape. Now there's the cylinder. The volume for this cylinder equals to pi r square h. The curved surface area. My curved surface area is basically this part. This part, not obviously the circular part. The curved surface area for this cylinder equals to 2 into pi r h. And again, just like those first two 3D shapes, if you open the cylinder's top part, the total surface area, it should be the curved surface area plus the downward circles area. Therefore, 2 pi r h plus pi r square. And if you sorry, if you close the top part of the cylinder, the total surface area should be same as before, and you will be adding one more pi r square. Therefore, 2 pi r h plus pi r square. Okay. Now, here here you have a question that what if you cut the whole cylinder into one third part of it. So here this is the cylinder and cutting in progress, and this is the result. So this shape is called a cone. Mm, so you must have seen a conical shape. If you celebrate birthdays, that time you must be wearing a hat over your head, and you must have eaten ice cream of a conical shape, etc., etc. That's the thing. Okay. So now let's discuss about cone. So here, this is the cone. Here, this is the radius of the circle. This is the perpendicular height of the cone, and this L represents the slant height. That's right, guys. This is the slant height. Hmm. Here, how will you determine the slant height? Here, this is the formula: L square equals to h square plus r square. So this theorem is mainly known as the Pythagoras theorem. I hope you guys are aware about this theorem, and if you haven't learned, you will get to know in the upcoming video, but not in the next video, in any of the videos I upload. So the volume of the cone equals to one third of volume of cylinder, therefore one third pi r square. Curved surface area for the cone equals to pi r l, and the total surface area for the cone equals to curved surface area plus area of circle, therefore pi r l plus pi r square. So I hope you guys are clear. Now another question. Now what if you just cut the top part of the cone? Yeah, let me repeat. What if you just cut the top part of the cone? So here this is the basically the cone, and if you cut it, if you cut the top part, and this is what you get the result. Mm, we call this shape a frustum, uh, and you must have seen a frustum such as a frustum lampshade, and well, as far as I can remember, I have seen myself this shape in the frustum shaped lampshade. Okay, now let's discuss about frustum. Well, first term here basically this is the easiest one here. Mainly you need to know the volume of the whole cone. Therefore, the larger cone's volume minus a smaller cone's volume. So for a smaller cone, you have to know the radius of the base of the base. Now the curved surface area for first term is basically and the curved surface area of large cone minus a small cone. A small cone, and the total surface area equals to this circle top surface area plus bottom surface area plus curved surface area. The simple concept. Now the next we have is a sphere. So you must have seen a spherical shape, a spherical tennis ball, and others, and many more. This is the sphere. The volume of the sphere equals to 4/3 of pi r cube. Then curved surface area of the sphere equals to 4 into pi r square. The total surface area is basically just the curved surface area. Therefore, 4 pi r square. Now, the next shape we have is a hemisphere. So, hemisphere is basically if you cut the sphere into half part. So that time you will get two hemispheres. Okay. This is the hemispherical shape. The volume of the hemisphere is basically the half of the volume of sphere, therefore 2/3 of pi r cube. Curved surface area is obviously the half of the curved surface area of sphere, therefore 2 pi r square. But the total surface area for the hemisphere is equal to and the curved surface area plus the bottom circle's area. Then therefore 2 pi square plus pi square which is equals to 3 pi square. Please, I want you guys to not get mixed up with this stuff. The sphere's total surface area equals to 4 pi square and hemisphere's one is 3 pi square. Now the next we have is a prism. Before that we have to know what does prism mean. What is a prism? Here it says a prism is a three-dimensional shape that starts and ends with the same 2D shape. Yes, that's right guys. So here you can see two types of shapes. This is the first prism here. As the shape started with a trapezium of the same length and heights, and the slant heights, then it also ends with the same shape. Then same goes for this triangular prism. There and many more. Okay, so no matter the prism shape, whatever the prism shape is, the volume of the prism is always equals to cross section area into length. Here cross section is basically the part I shaded, area of shaded part into length. Length is this one. And the total surface area for prism is basically just sum of the areas of the outer faces. Here, so for this prism, you will add the areas of this, and this, and for this shape, this, and this. Okay, I hope you are getting me, guys. Okay, so now the next we have is a pyramid, and you must have, I know you must have seen a pyramid you can see pyramid in Egypt or you can, and you must have eaten the chocolate named Toblerone. This is basically the pyramidal shape, etc. It can be anything. So now let's talk about pyramid. So here Yeah, it's basically just like the cones, just like the cone. This is the perpendicular height, and this is the slant edge, and this sharp part of the pyramid is basically called the apex. Okay, so now volume of the pyramid equals to one third of base's area or area of the base into vertical height. And total surface area for a pyramid is mainly nothing. Just you will add the base, the area of the base, and the triangular faces total area. Okay, and now here we go. Here we can say summary two, and just like in the first video, therefore the video I discussed about 2D shapes, you must have seen this type of asterisks, right? Exactly. And so here we can see two asterisks before the words volume and total surface area. Uh, okay, now let's see what does summary 2 say. Here it says that each of the 3D shape has their fixed formula for volume, but it has no fixed formula for the total surface area. Why? Because total surface area is basically equals to the sum of all the areas of the outer faces only. Exactly. Exactly, guys. And just remember these two and remember these two summaries, and you can note it down anywhere else. And but mainly you have to keep this in your mind that no fixed formula for volume, and and they have fixed formula for volume but no fixed formula for total surface area, because total surface area equals to sum of all the areas of the outer faces only, just the outer faces, nothing else. Okay, so that's it, guys. So hope you guys have enjoyed the video. If you did, please do not forget to like the video and subscribe my channel. Thank you, guys.